Okay, this section is on other types of angles as they pertain to circles. So we're going to learn about three types of angles. We're going to learn about angles that are on the circle, angles that are inside the circle, and angles that are outside the circle. And each of them have different rules that pertain to each of them. And you guys need to be expert on each of these types of rules. We're going to start here with Theorem 10.12, and then we're going to draw this picture of what I'm describing here. So Theorem 10.12 says this: if a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So let's draw what this describes. Here we have a tangent first. So remember, a tangent is a line, has to be a line that intercepts the circle at exactly one point. This is pretty good. Oops. So we have a tangent and then a chord. So we have a segment whose endpoints are on the circle, and they intersect at the point of tangency. Then the measure of each angle formed, so as you can see, there's two angles here. So let's label some points. We're going to label each of the points that I'm drawing here. We're going to label this one as A, this will be B, this will be C, and this will be D. So AB is the tangent, CD is the chord. We have angle ACD, and that's right here. We have angle BCD, and that's right here. Okay, so just to kind of get our bearings for a second. So if a tangent and a chord intersect at a point on the circle, here we have a tangent and a chord intersecting at point C, then the measure of each angle formed, that's the measure of angle ACD and the measure of angle BCD, both of those angles that are formed, are going to be 1/2 the measure of their intercepted arcs. Okay, well, this angle here is intercepting this arc, and this angle here is intercepting this arc. So now, this is kind of the same as Theorem 10.8, which says that an inscribed angle is 1/2 the measure of its intercepted arc. It's pretty much the exact same rule, that each of the measure of these angles, ACD and BCD, will be exactly 1/2. And remember, when we take 1/2 of anything, that's the same as multiplying something by 1/2. Will be 1/2 the measure of its arc. So this first angle, ACD, that angle intercepts arc CD coming this way. So we're going to add a point here. I'm going to add a point E, and I'm going to add a point F. You'll see why in a second. You might already see it. This angle intercepts arc CED. And this angle intercepts arc CFD. So each of those angles are going to be 1/2 the measure of those arcs that they intercept. This angle here, BCD, it intercepts this whole arc right there, arc CFD, and this angle right here, it intercepts arc CED on the circle. Okay? So let's do these practice problems really quickly. The measure of arc ADB is intercepted by this angle 130. So if this arc is intercepted by an angle of 130, then this angle must be 1/2 of this arc. So if this angle is 1/2 of this arc, then this arc will be 2 times that angle. So this arc will measure 2 times 130, and 2 times 130 is 260. And the measure of AB, well, how will we find that? Well, if this is a line, then that means the measure of this line must be 180. Well, if this part, you can see that this angle and this angle actually form a linear pair. It's been a while since we've talked about linear pairs, but a linear pair, if you remember, measures 180. So if this is 130, then this angle over here has to be 50. And if this angle is 50, then this arc that it intercepts is going to be 2 times that. So 50 times 2 is 100. Now, if I've done this right, you can see both of these arcs cover the entire circle. So if I've done this right, then this arc plus this arc should be 360, and you can see 260 plus 100 is obviously 360. Now, this one is a little bit harder. It's the same concept, same idea, but this is a great example problem for something that would be on your test. So now that we've done this one together, I actually want you to take your time and do this one on your own, and when you have done it, come and check it with me. We're not going to go over it in the video, so you will need to check it with me. All right, moving right along. What about angles that are inside the circle? Well, if two chords intersect in the interior of a circle, so let's draw that right here. One chord, a segment whose endpoints are on the circle, another chord. If two chords intersect in the interior of a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Wow, that is a lot of words. It's a lot of language that we've used. Let's dissect this a little bit. So, two chords intersecting in the interiors of the circle. That's what we have here. The measure of, excuse me, the measure of each angle. Okay, so we'll talk about just this angle and this angle here. Now, we know that those angles are vertical angles. And if you remember way back from semester 1, vertical angles are congruent. Always. VARC, vertical angles are congruent. So these two angles must be congruent. Well, the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So this theorem actually isn't talking about two angles at once. It's talking about one angle at a time. And I'll show you what I mean on this picture. Let's just think about this angle right here. Okay, and we're trying to find that angle. What this theorem says is that this angle right here is going to be 1/2 the sum of the measures of the arcs intercepted by the angle. What arc is intercepted by this angle? Well, clearly this arc right here is intercepted by that angle. So it's going to be 1/2 the sum of that arc and the angle by the angle and its vertical angle. So it's the sum of this arc and the arc that's intercepted by that angle's vertical angle. Okay, so there's that arc right there. So this angle right here is going to be 1/2 the sum of these two arcs. I'm going to add some notation so that we can talk about this in depth. I'm going to call this point A, this point B, this point C, and this point D. Here's what this theorem says. That the measure of angle, and I'm going to call this point in here M. The measure of angle AMD, that's this angle right here, is going to be 1/2 the sum of measure of arc AD. Now we have to make sure that we know it's an arc, so we put that. We put this little curved line. And its vertical angles intercepted arc, which we talked about a second ago, is arc BC. Now, if this isn't making sense to you right away, that's totally okay and totally normal. This is a very complicated theorem. But here's the idea that you have to understand. I could pick any angle in here. I could have picked this one. And the measure of that angle, what I need to do is take the measure of its arc, add it to the measure of its vertical angle's arc, multiply them by 1/2, and that's how I will find this angle. This is for all angles inside of the circle. We talked about on. This is for all angles inside the circle. Okay, so we're actually going to do a couple of practice problems now that will show where we will show this. Okay, here they are, and we're actually going to do both of these together. We're going to set up this theorem just like we described. What we're looking for is we're looking for the measure of angle DEB. That's this angle right here. If this is E, then the measure of angle DEB will be that angle there. We don't know what it is, but since we have two chords intersecting in the interior of a circle, we do know that the measure of angle DEB will be 1/2 times the sum of its intercepted arc, which clearly its intercepted arc right there is 180, and the arc intercepted by its vertical angle. Well, this is its vertical angle right there, and we can see that the arc intercepted by its vertical angle is 70. Okay, so I'm going to add those two arcs together, divide them by 2, or multiply them by 1/2. Those are the same thing, and I will get the measure of angle DEB. 180 plus 70 is 250. And 1/2 times 250 is 125. So the measure of angle DEB is 125 based off of theorem 10.13. Okay, now this time we're looking for the measure of arc DEB. This time what we're going to do is I'm going to set this one up for you, and then I actually want you to finish the math. Now, this time, look, we're not looking for the measure of angle DEB. We're looking for the measure of arc DEB. We're looking for the measure of this arc. But we actually are going to use the same theorem to help us figure that out. Why? Because what we know is that the measure of this angle right here, which is 120, is going to be 1/2 times the sum of its intercepted arc, which is DEB, and the sum of this arc and its vertical angle's arc. 120, the vertical angle is here, and the measure of that vertical angle's arc is 70. Can we actually solve this? Yes, we can, and we actually can take a couple of routes to get there. What I want you to do is I want you to go ahead and do this on your own. Finish solving this problem, and what we're looking for is we're looking for this value here. You're trying to isolate that and get it by itself. Okay, go ahead and do that now. And when you're done with that, go ahead and check it with me. And now that you've finished this problem, we're going to go ahead and move on to our last theorem. And this one is probably, this one's not quite as difficult as theorem 10.14. But we're going to do this, we're going to practice, and then I have your practice problems as the last, some of your practice problems at the last slide of these notes. So theorem 10.14 says this: if a tangent and a secant, or two tangents or two secants, intersect at a point outside of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. I have 3 circles here because we're going to draw each of those pictures. First, let's draw a tangent and a secant, and they must be intersecting at a point outside of the circle. Remember, a tangent is a point that intersects the circle at exactly what is a line that intersects the circle at exactly 1 point. So there's our tangent. A secant is just a line going through a circle. So I'm going to draw a circle, and it must intercept with this tangent at a point outside the circle. So I'm just going to draw a line right here. Boom. There we go. That's a tangent and a secant. Now we're going to draw 2 tangents. I'm going to draw it in red since I already drew the first tangent in red. Here's one. It's pretty good. And here is my attempt at another. It's pretty good. Okay. 2 tangents. They intersect here. And then 2 secants. 2 secants that go through the circle and intersect at a point outside the circle. There we go. They intersect right here. All 3 of these scenarios, the math here is the same. And as you can see, we have formed 3 angles. There's one angle right here. There's one angle right here. And there's one angle right here. And what we know is that the measure of this angle that is formed is going to be 1/2 the difference of the measures of the intercepted arcs. That's plural. Here's why. You can see that these angles that are formed have actually intercepted 2 arcs. One arc there and another arc here. That's 2 arcs that it intercepts. For this one, there's one arc right there, and there's one arc right there. For this one, 1 arc and 2 arcs. Now, we already know a rule about two tangents intersecting outside of a circle. And what that is that these two tangents must be equal. This distance from here to here, this distance from here to here have to be equal. But now what we know is that when a tangent and a secant, two tangents or two secants intersect outside of a circle, then the angle that's formed is going to be 1/2 the difference, so I'm subtracting them, 1/2 the difference of the measures of these intercepted arcs. Okay, so I'm not going to go into as much detail on this one with writing out the exact notation, but what you need to know is that when you're solving, you need to set this angle equal to 1/2 times the difference of these two arcs. And remember, this is when angles intersect outside of a circle. Let's do some practice problems here. All right, this first one, excuse me, it's asking for the measure of angle ABC. That's this angle here. And what we have is two secants. These are two secants because they're two lines that are going through a circle. And what we know, I'm going to try and move this one down here. Okay, very good. What we know is that this angle that is formed, ABC, will be 1/2 times the difference, so we're subtracting of these two intercepted arcs. One arc that's intercepted, two arcs that's intercepted. 70 subtraction, because it's the difference, minus 30. 70 minus 30 is 40, so we need to take 1/2 of 40, and 1/2 of 40 equals 20 degrees. So this angle right there that is formed is 20 degrees because of theorem 10.14. Okay, now it's asking us for the measure of arc DC. You can see that's this arc right here. Okay, and so we need to set up theorem 10.14 for this circle, and what we have is we have a secant and a tangent, so theorem 10.14 does apply. And what we know is that the measure of the angle formed, which is again is that angle right there, that's 50. 50 is going to be 1/2 times the difference of the intercepted arcs. This arc is 140 minus, we don't know the measure of arc DC. And I'm going to work this out. Now I'm going to show you a trick that I use to do these problems. And it's a lot easier to do these problems if we don't have to work with fractions when we're distributing. Distributing 1/2 into this parentheses just kind of makes things a little bit complicated. So something that I do is I take this whole problem and I just multiply it by 2. Why do I do that? Because 2 times 1/2 is 1. So when I multiply the right side of this equation, this 2 and this 2 just cross out, and what's left is just what's in the parentheses. Okay, but remember, anything I do to one side of an equation, I must do to the other. So 2 times 50 is 100, and 2 times 1/2 is 1, and 1 times 140 minus the measure of arc DC is just 140 minus the measure of arc DC. Now, could I distribute this 1/2 in and get the same answer? Absolutely I could, but this might be a little bit easier for you. All right, so now I need to get this by itself, so I'm actually going to add the measure of arc DC over to the other side, and I'm going to subtract this side by 100, both sides by 100. And when I add this over here, I get the measure of arc DC is 140 minus 100, which is 40 degrees. Okay, so the measure of arc DC is 40. And now we have a third problem here, and this one is once again a great type of question that will be on your test. So I want you to give it your best shot. It's a little bit more difficult. These have kind of all gone up in difficulty, so this one's even a little bit more difficult. Give it your best shot and check it with me when you're done. Then when you're done with that problem, you can see in your notes you have an entire kind of cheat sheet here that will help you. What I might do is I might write down each of the rules as it pertains to this picture on your cheat sheet. Okay, so for example, for this one, we could say the measure of arc AB is X. Okay, and then I'm writing central. That's the only word I'm using, so you only can use one word per picture, and you're not cheating. This one would be on, and this one, if we have an inscribed angle, then the inscribed angle X is going to equal 1/2 of its intercepted arc, which is arc ACB. And you can go along. I would put all of these on your cheat sheet. Okay, I would draw them and I would write these rules. This will help you tremendously. And if you need help doing this for inside and outside, you can refer to your notes, or you can take the time to come and ask me. That's why I'm here. Okay, so after you have done this problem down here, check it with me. I would add all of this to your cheat sheet, and then you can work on your practice problems, which are on PowerSchool. All right. Thanks, guys, for your level of attentiveness, and I will see you next time.